Hello guys, welcome back to the channel, and today let's configure advanced OSPF. So in this practical, we're going to configure stub area and also stub area. So it's important to understand the difference between stub and not so stubby area. So stub area is an unbackbone area with only one ABR. So the ABR here receives the external AS routes, but it doesn't advertise it in a stubby area. While not so stubby area, we have got the ABR and all the ASBR. So the ASBR here advertise the type 7 generates type 7 LSA. So when the type 7 LSAs reach the ABR converts the type 7 LSA into type 5 LSA. Then type 5 LSA is being flooded in a autonomous system. Also, the NSSA, that is not so stubby area, advertises the external routes into the NSSA. That's the difference where it comes with stub area. With a stub area, you can't advertise the external routes, so that's help reduce the number of routes in a routing table and also minimize the number of router resources being used. So that's why we employ stub area to help reduce the number of routing entries into the routing table. So that's what we are going to configure. We're going to configure stub and non-so stub area. So this is our topology. So there's a requirement here that when configuring a stub area, note that a backbone area cannot be configured as a stub area. Number 2, prior to the configuration, configure stub area attributes on all routers in the stub area. ASBRs cannot be part of a stub area. Note that I said the ASBR is only found in not so stub area, where when the type 7 LSS is generated and it reaches the ABR, it is being converted into a type 5 LSA. As external routes cannot be advertised within the stub area, so like I just said, you can't advertise external routes within a stub area. That's help reduce the number of routing entries. A virtual link cannot pass through a stub area. So those are one of the keynotes in a stub area. While when you come to a not so stubby area, these are the keynotes. A backbone cannot be configured as an not so stubby area. Prior to the configuration, configure NSSA attributes on all routers in the area. Virtual link cannot pass through the NSSA. So that's about it. Guys. So that's what we are going to configure here. We're going to configure the stubby and also stubby. So we enter into our router 1. On router 1, we're going to this is a serial interface. It is different within downwards. These downwards are gigabit interface, while this the upper is a serial interface. So on switch 1 or router 1, we're going to configure loopback 0 and also the network of 12.0.12.1/24. Interface loopback 0 with IP address of 10.0.24. Then quit and enter the serial interface. So interface serial 0/0/2 IP address of 10.0.12.1/24. Quit, and after that you also come to this second router here and give the IP addresses. So interface serial 0/0/2, IP address of 10.0.12.2 here /24. Then the next network will be IP address for serial 1 here will be .23. So serial 1 IP address of 10.0.23.2/24. Then for the gig 2, interface gig 2, so you quit and create the gigabit interface. So interface gig 0/0/2, IP address will be 10.0.2524.2/24. After that, you quit and create the loopback. So interface loopback 0, IP address of 10.0.2.2/24. Quit and go to this fourth router here. So here we are going to create interface loopback 0. Interface loopback 0, we give it IP address of 10.0.4.4/24. You quit and go enter the gigabit 2. So interface gig 0/0/2, IP address of 10.0.24.4/24. Quit and go to router 3 here. You're going to add loopback interface and serial 1 and serial gig 2. So interface loopback 0, IP address of 10.0.3.3/24. Quit and enter interface serial 0/0/1. You give it IP address of 10.0.23.3/24. Then interface gig 0/0/2. Quit. Interface is 0/0/2. IP address of 10.0.35.3/24. So after that, quit and save. Then next is router 5. You're going to create loopback. So interface loopback 0, IP address of 10.0.5.5/24. You quit and enter interface gig 2. Interface gig 0/0/2, IP address of 10.0.35.5/24. After that, we are going now to configure the areas. So as you know, switch router 5 here, it's going to ask at our NSSA not so stubby area. So area 1 here is going to act as our not so stubby area, while area 2 here is going to act as our stub area. Then area 0 is the backbone. Router 5 here is going to be ASBR. Is going to be the ASBR is going to generate type 7 LSA. After it generates type 7 LSA, then router 3 here, which is the ABR, is going to change that type 7 LSA into type 5 LSA. Then it floods it in the area 0, that is the backbone area. While this router 2 here is going to act as the ABR for a stub area, that is area 2. So when router 2 here receives the AS external routes, it won't forward those, it won't advertise those routes into the stub area. This helps reduce the number of route entries in the stub area. So you enter the stub area, we are going to advertise how many networks. So the network for the loopback and this network of 10.0.12.0. Process ID, we are going to use a process ID of 1. Router ID here is for the loopback interface, that is 10.0.1.1. Router ID, to complicate the router ID, this is area 2. Area 2, we advertise the network of the loopback, so that is network of 10.0.1.1, and we put it at 32 base 0.0.0.0. Again, we advertise the network of 10 .0.12.1, wildcard mask of 0.0.0. After that, you tell it this is a stub area, stub, and display this. As you can see here, we configure the area there as stub. Then we come to switch. We come to router 2 here, and router 2 also we are going to configure the areas. So router 2 here, we have got how many areas? Router 2 here, we are going to configure 3 areas, that is area 2, area 0, that is the backbone, and area 3. So OSPF process ID of 1, router ID of 10.0.2.2. area here will be, first area will be area 0. So area 0, we advertise the network of 10.0.23.0 and the loopback. So area 0, network of 10.0.2.2, wildcard mask of 0.0.0, and a network of 10.0.23.2, wildcard mask of 0.0.0.0. Quit and enter area 0, area 1, area 2, area 2 here. Area 2 here, we address the network of 10.0.12.2, wildcard mask of 0.0.0.0. This will be 12.12. Let's see. It is 10.0.12.2 on this interface, on this router 2 here. 12.2, the wildcard mask of that. Then we tell it this is a stub, no summary, that is stub, no summary. After that, you quit and enter area 3 here. On area 3 here, we are just going to advertise the static routes. So here we are going to involve the static routes. Now we are going to advertise the static routes on that. So area 3, network of 10.0 10.0.24.2 wildcard mask of 0.0.0.0. So after advertising that network, we are now go to area. Now go to that router 4 and OSPF here, OSPF process ID of 1. Router ID here will be 10.0.4.4. and now the area here will be area 3. Before we quit, but here we said we're going to advertise, we're going to configure the static route, so we are going to advertise the default route. So default advertise route cost here will be cost of 20, and the type here we give it a type 1. We're going to advertise that default route. The default route we're going to create on that router, so the area will be area 3. On area 3, advertise the network of 10.0.24.4 I'll get a mask of 0.0.0.0, and after that you quit and configure the static routes. The static routes we are going to set it to any address. So then the outbound interface is going to be at the loopback 0. So IP route static 0.0.0.0 wildcard mask of 0. Then our outbound interface will interface loopback 0. So that's going to be the outbound interface. So after that we save. Then come to on this our router here. Here we are going to advertise the network of 10.0.23.0 and for the loopback 0, and also for the network of 10.0.35. Then we are also going to tell it to interact with the NSSA, that is not so stubby area, because this one is going to be the ABR. It's going to convert type 7 LSA into type 5 LSA. So we're going to configure it as NSA. So OSPF process ID here is the one. Now the router ID here will be 10.0.3.3, and that we're going to address the network of area here will be the first area will be area 0. Address the network of 10.0.23.1.3 wildcard mask of 0.0.0.0. Then the next network we are going to advertise will be the next network. So you can see the LSS have been exchanged. The next network will be network of 10.0.3.3, that is for the loopback 0.0.0.0. You can mask of that. After that you enter area. You're going to enter area 1 here. Area 1 we add the network. So create area 1 here. We're going to add the network of network of 10.0.35.3 wildcard mask of 0.0.0.0. Then we tell it this is an not so stubby area. After that you quit and you save the configuration. Then you come to this our last switch and also configure the not so stubby area on that router 5. So OSPF here, process ID of 1, area here is going to be area 1. In area 1 we are going to give it a network of 10.0.35.5 wildcard mask of 0.0.0.0. After that you tell it this is a not so stubby area, and once it has as it's being the ASBR, it will convert type 7 LSA. After that you quit, say yes, and display IP routing table. When you display IP routing table, you can see one route has been learned through NSSA, that is not so stubby area, and some routes have been learned through OSPF. That one has been learned through OSPF. Also, let's display IP. The IP routing table. You can see the routes that have been learned through the type of LSS. You can see those routes, and also when you come to switch router, this router 2 here, display IP routing table. You can see the default route of 0.0, the default route that was advertised. So let's see if we can ping. Can we ping the 10.0.5.5 can't reach while on this network? Can we ping? We want to ping 10, this network of 10.0.23.2. So ping 10.0.23.2. It's able to reach that network. Out of a network of 10.0.1, so ping 10.0.1.1. Does it know about that loopback? So the reason why it can't ping that, let's try while on this network, tell it to broadcast, enter the loopback 0. So interface loopback 0, display this. Let's try to give it a network type, so OSPF network type a broadcast, and also come on this other router here and enter the loopback. So interface loopback 0 and give OSPF network type. Here we used a broadcast, then we broadcast that network and see if we can ping now. Still we are not able to ping, so we are trying to troubleshoot. Let's try and troubleshoot. So let's see if we can ping ping 10.0.12.1. that is on router 1 here, while we are on router 5. So enter router 5. So ping 10.0.12.1. Can't reach that guy, but while the link is down, as you can see, the serial link is down. Let's give it time. So meaning that you are sending packets, and when it gets into that serial interface, the packets are being discarded. So let's interface, let's check, bring that interface up. So interface serial 0/0/2, display this. Interface is up, but while on this router, let's try display quit and interface serial 0/0/2, display this. You can see the interface is shut down. The interface is shut down, so we are going to undo shutdown on that interface. So undo shutdown to bring that interface up. So the interface is now brought up. So while on router 5, let's see now if you can ping after bringing that interface up. So ping 10.0.0.12.1, or it's able to go through. Well, you can see also it's now able also to configure to ping the loopback. So if you ping the loopback of 10.0.1.1, it's able to ping. Now while on router 5, let's see also if you can reach router 4 here. So on router 4, ping 10.0.24.4. The packets are able to go.